looking at equations with two missing numbers. For this video, it's recommended that you're familiar with addition and subtraction facts. Definitely number bonds up to 100 are really useful here. Inverse operations, understanding how addition and subtraction are the inverse of one another. Basic algebra, substituting in algebra, and balancing equations. The sum of the cards below is 16. We know that y equals 3. What are the possible whole number values of x and z? We know what the y's are worth. We've got to find out what the x's and z's are worth. We know that there's more than one possible answer. Something to be aware of here, the word sum is overused a lot in maths. It tends to get used for all kinds of operations. When we're asking for the sum of anything, we want them to be added together. The sum of x, y, and z is 16. First thing we can do here, something that we've covered in one of the other algebra videos, is substituting. If we know what one of the values is, we can put the number in there instead of the letter. We know that the y's are worth 3, so where we have y, we'll just substitute it with 3. We also start introducing the concept of simplifying here. If we have 3 add 3, we know that that's 6. So we can simplify this equation to say x add 6 add z is 16. And it's just a little bit simpler. There's one less operation in there. So I've set out that equation again here, and I've used different colours for different representations. X plus 6 plus z is 16. We know what that 6 is worth. If we take that 6 out of the equation, remember that that equal sign means is the same as. So whatever is on one side of that equal sign has to be exactly the same as what's on the other. If we're going to take that 6 away from that side, we also have to do the same on the other side to keep it balanced. So we simply take that 6 out. The 16 becomes 10. We've taken the plus 6 away from the other side of the equation, so we now just have x plus z. Now we know that 2 x's and a z equals 10. And we can simplify once again, because what we have here are 2 x's. In algebra, if you have two letters or symbols the same, they have the same value. So we know that that is the same as 2 lots of x. And remember from previous videos on the basics of algebra, if we have 2 lots of something, we just write 2, whatever that thing is. So 2x just means 2 times x. And to finish that equation, 2x plus z equals 10. Now I'm going to be systematic and try to work out what the x and what the z could be worth. And to do that, I'm going to substitute numbers instead of letters. For the purposes of this video, I'm including only significant numbers. I'm not going to be using 0 as any of the possible values, but just be aware that there are some maths questions where 0 could be represented by one of those letters. I'm going to start by saying, what if x equals 1? If x is 1, that 2x, which means 2 times x, represents 2 times 1, and 2 times 1 is 2. So that would be 2 add z equals 10. Now we can use the inverse operation to work out what that z is if x equals 1. 10 take away 2 is 8. So if x equals 1, z equals 8. Continuing with being systematic, I'm now going to say, what if x equals 2? If x is 2, then 2 times x is 2 times 2, and that's 4. I'm going to put the rest of that calculation in. Plus z equals 10. 4 plus z equals 10. Use the inverse operation. 10 take away 4 will leave you with z, which is 6. If x equals 2, z equals 6. Now let's try 3. Interestingly here, something important to remember in algebra, we already have y equals 3. If y equals 3, another letter cannot equal exactly the same in this case, so we can't have x equals 3. So we're going to get rid of that one and try the next number. X equals 4. If x equals 4, then 2x is 2 times 4, which is 8. 8 plus z is 10. So what would you add to 8 to get 10? Well, that's 2. So if x is 4, then z is 2. So you have 3 possibilities for the values of x and z. This is the same kind of thing, and this is one for you to try. The sum of the cards below is 20. Remember that the sum is adding them together. A equals 5. What are the possible whole number values of B and C? So there's going to be more than one answer. Pause the video, see how many possible combinations you can find for the values of B and C. First thing you can do is substitute. We know that those A's are worth 5. Now we have 5 add 5, add B, add B, add C is 20. We can simplify that. 5 add 5, that's 10. So we've made our calculation slightly simpler. 10 add B, add B, add C is 20. Now we can start looking at what we can get rid of to help us work out what's left. If we can get rid of that 10, that'll help us to work out the B's and the C. But remember, if we're taking 10 away from that side, we have to balance it and take 10 away from the other side of the equal sign. So if we take 10 away from this side of the equal sign, we're left with B add C. And if we take 10 away from the other side, 20 take away 10 is 10. We now have B add C is 10. We can simplify that a bit more because we have 2 B's and we know that they have to be of the same value. 2 B's is the same as 2 times B. 2 B's plus C equals 10. Now we can start substituting numbers. Let's say B equals 1. That means that 2 times B is 2 times 1, and that's 2. If we add C, we get 10. So 10 take away 2 gives us C, which is 8. If B equals 1, C equals 8. But now let's see what happens if B equals 2. That means that 2B is 2 times 2, and that's 4. If we plus C, we get 10. 10 take away 4 is 6. So if B equals 2, C equals 6. Let's say B equals 3. 2 times 3 is 6. Add C, that equals 10. 10 take away 6 is 4. So if B equals 3, C equals 4. Now let's try B equals 4. 2 times B is 2 times 4, which is 8. Add C equals 10. 10 take away 8 leaves you with 2. So if B equals 4, C equals 2. If you found this video helpful, please click the thumbs up button and subscribe to my channel.